2.3 in the book. Composition of functions. You'll compose two or more functions as one by evaluating one function with another. So we'll go more into detail from the objective. The composite function f of g, the composition of f and g, is defined as f of g, which equals f of g of x. I prefer this way because you're used to f of x, so it's a little bit easier to say f of g of x. So you're taking whatever g of x and you're plugging it into f of x. The domain, here we go. Now, do not confuse these with 8.2 stuff. The domain of f of g is the intersection of the domain of g and the domain of f of g. So g is what's being plugged in, so that domain remains, but we're pulling out any restrictions. We're literally pulling out any restrictions from f when we place it with g. So the restrictions of g remain, and then once you put together, look for any other domain issues. So this one here, given the function blah and blah, find the following: f of g at 1/3. So on this one, oh, I need to go back on this one. I need to identify, I think I said this is preferred one. If I do a test from the test generator, it'll have this. If I write it myself, it'll be this. You have to know both. Okay, so f of g of 1/3, they're really asking you f of g at 1/3. So they want g at 1/3, and whatever that value is, you're going to plug it into f, just like PIMDAS, and work from the inside out. So let's start with g at 1/3. G at 1/3 is equal to 1/3 squared minus 2 times 1/3 minus 6, which is going to be 1/9 minus 2/3 minus 6 over 1. We need a common denominator. So since this is 1, 3, and 9, we're going to go with 9. So let me change my color pen so you guys can see what I'm doing here. I'm going to multiply top and bottom here by 3. That'll give me 9. And top and bottom here by 9. So I now have 1 minus 6, 2 times 3, minus 54, all over 9. If we do our math, 1 minus 6 is -5. -5 minus 54 will give me -59 over 9. That's g at 1/3. I need f at 1/3, so, or f of g. So now I do f at -59 over 9. F is 3x plus 1 equals 3x -59 over 9 plus 1. This is going to reduce with this guy and leave it as 3. So I have -59 over 3 plus 1, or 3 over 3, which is going to leave me -56 over 3. And there's our answer. That is the easiest way to do this. Just put -1/3, or put the 1/3 into G, calculate, take that value and plug it into F. Okay. All right. So find f of g and g of f. I'm going to take a little, actually I'm going to set this up. Okay, so let's look into if we didn't have a number. They want f of g of x, which is just f of g of x. So I'll do that one on this side, f of g of x. So really, g of x is x squared plus 5, so I really want f of x squared plus 5. So in f of x, everywhere I see x, I'm going to replace it with x squared plus 5. So this is going to be 3 times x minus 2. And now I can plug this x squared plus 5 into here. So this is going to give me 3x squared plus 15 minus 2, or 3x squared minus plus 13. Now it also asks for the domain. The domain of each of these are all real numbers, so that anytime you put all real numbers together as a composition, your domain will be all real numbers. Okay, so let's try it the other way. G of f of x. So I really want g of 3x minus 2. That's f of x. So everywhere I see an x in this guy, I'm putting this in place of it. So I have x squared first, so x squared plus 5. By the way, I put the parentheses here. I say x, but I don't write x. That way, I don't forget to do all of my substitutions. Plug in 3x minus 2 for my parentheses, and distribute. Well, remember we did this one just a few days ago. 3x minus 2 squared. So we have a plus b squared is going to be a squared plus 2ab plus b squared. So this one squared would give me 9x squared. 3 times 2, 6 times 2 is 12 minus 12x, and then 2 squared plus 4 plus 5. Don't forget that, plus 5. So g of f of x gives me 9x squared minus 12x plus 9. Yes, you should identify what this is. And again, they ask you for domain. And so remember, it is the domain of this guy, which is all real numbers, intersected with the domain of this guy, which is all real numbers. So all real numbers, negative infinity, positive infinity. Done. Okay, this one. Let's look at domains individually first. This one here, domain. Do I have fraction? Yes. Radical? No. Set that equal to 0. And I get a domain of negative infinity to 0, union with 0 to infinity. And this one has a domain of, you get 2x plus 1, so x cannot equal negative 1/2. So you get a domain of negative infinity to negative 1/2, union with negative 1/2 to infinity. Okay, now I'm going to stop on this one because this is just the domain idea. Do I have a fraction? Yes. Do I have a radical? No. On both of them. So you set them both equal to 0 and solve. But I do have it marked that I want to do this one, all of it, in class. So we're going to do all of this in class, the rest of this one in class. So let me just write to the side. This one's going to be done in class. Okay, so this one here, I have down that we're going to do only the domain part in class. The rest of it shouldn't be too terrible. So this one, the domain. Do I have a fraction? No. Do I have a radical? Yes. Set it to be greater than, if you're radicand, greater than or equal to 0, and solve. Oh, there, we're done. So it is 0 to infinity. And this one, do I have a fraction? No. Do I have a radical? No. All real numbers. Okay, so they're asking for f of g, which means it's f of 2 minus 3x. And f of x is radical x, so it's the square root of x, but now my new x is 2 minus 3x. So f of g of x is the square root of 2 minus 3x. Nothing more to be done here. Now, the domain, we're going to talk in class about domain. Okay. So this one is going to be g of f of x. So this is g of square root of x. So everywhere I see a square root, or everywhere I see x, I'm going to put in square root of x. So this gives me 2 minus 3 square root of x. And we're done. So g of f of x is 2 minus 3 square root of x. Yes, these are the kind that you will always hope that you get. Something very quick and simple to be done. And again, domain we'll do in class tomorrow. Okay, then they have your last one, probably a better one to do in class. But if f and g are linear functions, what can you say about the domain of f of g and the domain of g of f? Well, linear functions, the domain is all real numbers. And so if I put something with all real numbers into something with all real numbers, the domain is all real numbers. Okay, I could probably make this as one video, but I think that there's enough going on that we're going to separate the two videos. So maybe we'll just have two very short videos, because this is where I'm cutting this one off for now. So go ahead and try the one that I did skip and see how you do, and go from there. All right, good luck.